Today, I'm going to talk about some really interesting topics about how computer works, especially the CPU and GPU. I'll also explain SAP1 operations and programming. These are important because they help us understand how computer process information, run programs, and perform tasks efficiently. We'll dive into how the CPU functions, how it evolved over time, how GPU work, and how SAP won't help us learn the basic computing. Computers are all around for us, from smartphones to gaming consoles to smart home devices. They all rely on CPUs and GPUs to function properly. But have you ever wondered how these tiny chips can do so much? That's what we're going to explore today. So sit back, relax, and let's get started. First, how the CPU works. So let's start with the CPU or Central Process Unit. You can think of it as the brain of the computer. It takes instructions from programs, processes them, and then gives output. CPU works in cycles. They fetch an instruction, decode it, and then execute it. This cycles repeats over and over at an incredible fast rate. CPU use something called registers to store data temporarily while working on tasks. They also have a control unit that direct operations and an arithmetic logic unit or ALU that handles calculations. Modern CPUs even have multiple cores, which means they can work on multiple tasks at the same time, making them much faster than older single core processors. Another important feature of modern CPUs is cache memory. Cache is a small amount of a high-speed memory that stores frequently accessed data, so the CPU doesn't have to keep fetching it from slower main memory or RAM. This helps improve performance significantly. CPUs also have a different instruction sets, which define the types of commands they can execute. Some common instruction sets architectures include x86 used in most PCs and ARM used in mobile devices. The choice of architecture affects the performance and efficiency of a CPU. The evolution of CPUs, parts 1 to 4. Over time, the CPUs have changed a lot. In the beginning, they were simple and slow. The first CPUs, like the Intel 4004, could only handle basic calculations. But as technology improved, CPUs become more powerful. In the 1970s and 80s, we saw a rise of the x86 architecture, which is still used today. By the 90s and early 2000s, CPU had more transistors and higher clock speeds. Companies like Intel and AMD introduced multiple multi-core processors, which help boost performance. Today, we have CPUs with billions of transistors and advanced features like hyper-threading and turbo boost, making them super efficient. One key milestone in CPU evolution was the introduction of pipelining. Pipelining allows a CPU to work on multiple instructions and at the same time by breaking them into smaller steps. This helps improve efficiency and speed. Another major advancement of the transistor transition from 32-bit to 64-bit processor. A 64-bit CPU can process larger amount of data at once and access much more memory, making, making it ideal for modern computing needs. CPUs have also benefited from advancements in semiconductor manufacturing, allowing for smaller and more energy efficient design. This has made it possible to create powerful processors that consume less power, extending battery life in portable devices and reducing electricity consumption in data center. Overview of the GPU. While, while CPUs are great for general tasks, GPUs or graphic processing units are designed for handling graphics and heavy calculations. GPUs are used in gaming, video editing, and even artificial intelligence. They have thousands of smaller cores that work together to process multiple tasks at the same time. This makes them much better than the CPUs at handling large amount of data, especially when rendering images or running complex simulations. GPUs are designed for parallel processing, meaning they can handle many calculations simultaneously. This is what makes them so powerful in tasks like 3D rendering, deep learning, and cryptocurrency mining. Unlike CPUs, which focus on sequential processing, GPUs are built to process vast amounts of data in parallel, making them essential for modern computing applications. A key development in GPU technology was the introduction of CUDA, or Computer Unified Device Architecture, by NVIDIA or OpenCL or OpenCL or Compute Computing Language by AMD. These frameworks allow developers to use GPUs for general purpose computing beyond just graphics, opening the door for high performance computing applications. GPUs are also essential in scientific simulation, such as weather forecasting, molecular modeling, and space exploration. The ability of GPU to process complex mathematical models at high speeds has significantly advanced research in multiple fields. SAP-1 operations. SAP, or Simple as Possible 1, is a basic computer model for learning how CPUs work. It has simple components like a memory unit, an accumulator, a control unit, and an ALU. SAP-1 follows basic instructions like loading data, adding or subtracting numbers, and storing results. It helps beginners understand how computers execute instructions step by step. SAP SAP-1 uses machine learning, which consists of binary instructions that the CPU can understand. These instructions tell the computer what operations to perform. Understanding SAP-1 is essential for learning the fundamentals of computer architecture and programming. SAP-1 programming. Programming SAP-1 is simple but useful. It involves writing basic instructions in machine language. For example, we want to add we want for example, if we want to add two numbers, we write instructions to load the first number into the accumulator, add the second number, and then store the result in memory. This step-by-step process is similar to how real-world CPUs execute programs, just on much smaller scale. One example of SAP1 programming is writing a basic program that adds two numbers and stores the result. This step might look like the steps might look like this. First, load the first program into the accumulator. Second, add the second number to the accumulator. And lastly, store the result in memory. This process demonstrates how basic computing operations are performed at the machine level. While it may seem simple, understanding SAP1 programming helps us appreciate how modern computers handle complex tasks. Real-world application and the impact. Now that we've covered CPUs, GPUs, and SAP1, let's talk about how these technologies impact our daily lives. Without CPUs, modern computers wouldn't exist. Everything from smartphones to supercomputers relies on CPUs to function. GPUs have revolutionized industries like gaming, animation, artificial intelligence, and scientific computing. AI models, for example, use GPUs to process vast amounts of data quickly, making machine learning and more accessible and powerful. As for SAP1, while it's a simple educational tool, it serves as the foundation for understanding more advanced computing concepts. Many students and beginners start with SAP1 before moving on to more complex architectures. So, that's my reflection of these topics. Understanding how CPUs and GPUs work, along with learning about SAP1, gives a better idea of how computers process data. It's amazing to see how far technology has come and how it keeps evolving. The future of computing is exciting, with developments like quantum computing and AI powered processors on the horizons. I hope this reflection helped you understand the basic of these essential technologies. Thank you for watching. I appreciate your time and interest, and I hope you found this discussion valuable.